Okay, so in section 1.6, we're going to take a look at polygons, becoming familiar with them, and although we won't work with polygons immediately in the near future, we will spend a lot of time in this course looking at different types of polygons and their properties, etc., etc. So if we look here, a polygon is a closed plane figure. In other words, I mean, it's fully enclosed. I think that's pretty self-explanatory. So it's a closed plane figure with the following properties. It is formed by 3 or more line segments, which are called sides. Okay. And each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. All right, so again, that should make sense. All right, it wouldn't make sense for me to draw a polygon if I go 1, 2, and then I draw 2 segments here, 1, 2 that are right on the same line. That would just be considered one side of the polygon, not 2 different sides. That's essentially what that second part's describing. Okay, the sides of a polygon are the line segments that form the polygon. I think that's pretty self-explanatory. A vertex of a polygon is an endpoint of the side. It's all the points. You know, so for example, if I'm looking at this polygon here at the right, then your vertices, right? Vertices is plural of vertex. Your vertices are A, B, C, D, and E. All right, those are your vertices. A convex polygon is one in which no line that contains a side of the polygon contains a point in the interior. So in other words, if you trace all of the sides of your polygon and none of them go into your shape, then it's convex. Clearly, a concave polygon is one that is not convex. In other words, when you trace the sides of this guy, right? So I have one side, that one's good, that one's good, that one's still good, but then you'll notice if I trace this side here, I go into the polygon. Therefore, that makes that a concave polygon. Okay, concave, convex, you've probably talked about. Remember that regarding lenses. And so concave goes in, convex goes out. Okay, so naming polygons, you name it by listing the vertices in consecutive order. Okay, so in other words, we would call this guy polygon A, B, C, D, E. You don't have to go in that order. You could say E, D, C, B, A. It doesn't matter. The point is you would never call this thing polygon A, B, E, D, C, because what that would say to do is start at A, go to B, then to E, then to D, then to C, and then back to A, and clearly that would not be this polygon. Okay, so you just got to make sure that when you name it, you are naming it and you're putting your points in consecutive order. Okay, an n-gon is a polygon with n sides, so if I tell you that you have a 12-gon, it's got 12 sides. A 15-gon has 15 sides. Equilateral means that it's a polygon in which all of the sides are congruent. So we can look at an equilateral triangle, and again, remember the way that we mark this diagram to make sure that we know it's equilateral would be to do that, so we know all of those sides are congruent. An equiangular is about what you'd expect, and that means that all of your angles are congruent. So we would mark it like this. Okay, and we can look at equilateral and equiangular polygons. It doesn't have to be triangles, could be anything. So if you look at this shape here to the right, this guy has, let's see here, 1, 2, 3, 4, 5, 6. That's an octagon, okay? And we would actually call that a regular octagon because all of your sides are congruent, which makes you equilateral, and all of the angles are congruent, clearly, because it's marked here, and that makes you equiangular. So essentially, if you are equilateral and equiangular, we just, instead of saying both things, we just say that you're regular. Okay, everything's equal. Okay, all of your angles are equal, all of your sides are equal in measure. Okay, so example 1 here, we're going to look at concave versus convex. First of all, recognize that this guy here, that's not even a polygon. Okay, so we're not even going to talk about that. That is not a polygon because it's not a closed figure. You have this line segment in the middle here, which makes it not a polygon. All right. If I look at the second one, clearly just start tracing the sides. Okay, and as soon as you go into the figure here, that means that this guy is concave. All right, and a lot of these you can probably just look at and see. The next one, it's pretty clear that that's going to be convex, right? Trace all your sides. You're never going to go into the figure. And this last guy, again, is not a polygon because of this piece right here. You cannot be rounded and be a polygon. All right, cannot be rounded and be a polygon. All right, and then this area is just naming based on the sides. Okay, you should know these already, or at least most of them. So three-sided figure is called a triangle. Four-sided figure is called a quadrilateral. I'm going to just abbreviate here for time's sake. A five-sided figure is a pentagon. 6 is a hexagon. 7 is a heptagon. Let's see here. 8 is an octagon. 9 is a nonagon. 10 is a decagon. Should make sense, right? There's 10 years in a decade, so a decagon has 10 sides. Notice we don't have one for an 11-sided shape, so if you have an 11-sided polygon, you just call that an 11gon. And then a 12-sided polygon is called a dodecagon. Do means 2. Decagon means 10, so 2 and 10 makes 12. And then obviously anything other than that, we would just call it an n-gon. All right, so again, hopefully you're familiar with most of these. It's just important that you got this, so if I describe a situation to you and I say, okay, suppose you have a regular nonagon, you're not having to think, okay, what's a nonagon? I'm not sure what that is. So just make sure that you're comfortable with these different names. Okay, so we're going to classify the polygon by the number of sides, tell whether it's equilateral, equiangular, and regular. Okay, so the first figure, obviously count the number of sides. 1, 2, 3, 4, 5, 6. Hexagon. Are all the sides congruent? Yep. All the angles congruent? Yep. That makes you regular. Okay. At this point, I would probably pause the video and just kind of go through this on your own if you can. So figure number 2 is a quadrilateral, 4 sides. It is not equilateral. Okay, because again, these guys are congruent and these guys are congruent, but they're not all congruent to each other. It is not equiangular and it is not regular. Okay, this next guy has, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a dodecagon. Okay, is it equilateral? All the sides are congruent. It is not equiangular, therefore it's not regular. It's not equiangular because clearly, these two angles here are 90 and this one here is not. Okay, so that would not be a regular polygon. And finally, this last guy here, it's got 4 sides, 1, 2, 3, 4, so it would be a quadrilateral. It is equilateral. It is equiangular. Therefore, it is regular. Clearly, if you have a regular quadrilateral, we would just, if we're going to be more specific, we would just call that guy a square. Okay, and we'll get into more concepts of that. Okay, it says the head of a bolt is shaped like a regular hexagon. The expressions shown represent the side lengths of the hexagonal bolt. Find the length of a side. Really, the big thing here is the only geometry that's going on here is, do you know what this word means? If you know what regular means, then you know that that means this, which means that this guy and this guy are actually the same. Okay, so when you set up your equation, it's 4x plus 3 equals 5x minus 1, and then you just go to work here using your algebra. Okay, now be careful, right? It says find the length of a side, so I solve for x. You just want to make sure you plug that back in. 5 times 4 is 20, minus 1 is 19 millimeters. I would probably plug the 4 back into the other one just to make sure I get 19 again. Otherwise, if I don't get 19 when I plug it back in, I know I screwed something up. All right, so clearly that takes us to the end of the notes here. So really big ideas from today is what is a polygon, naming polygons based on sides, equilateral, equiangular, regular, and finally concave versus convex. We'll kind of hammer out some more details in class, but if you have any questions, be prepared to ask those first thing.